Kirsten. Welcome to Real World Science. There's just one star in our galaxy, and we call it the Sun. We'll learn all about the Sun and how the Sun affects us in the real world. Layers of the Sun. We know that the Earth has many layers, from the inner core of the Earth to the ground we stand on. But did you know that the Sun has layers too? The Sun may have layers like the Earth, but unlike Earth, the Sun is completely gaseous. Our Sun is actually a star. It may look small in our sky, 93 million miles away from Earth, but it is truly a gigantic ball of gas, made up mostly of hydrogen, but also contains helium and other elements. At the very core of the Sun, chemical reactions cause extreme heat that rises up and bubbles on the surface, or the photosphere. Once the gas has reached the photosphere, it cools and descends back down to the Sun's core to be heated up and rise again. The photosphere is the most visible of the Sun's layers and gives off light and has temperatures of about 6,000 Kelvin. Just above the bubbling photosphere is the chromosphere. The chromosphere is the layer of the Sun's atmosphere above the photosphere. The chromosphere has spicules, or long thin lines of gas that resemble grass growing up from the photosphere. These blades of gas rise up to the chromosphere and drop back down every 10 minutes. Extending just beyond the chromosphere is the Sun's corona. The corona is the outermost largest layer of the Sun's atmosphere. It extends millions of kilometers into space and has temperatures up to 2 million Kelvin. The corona is the faintly glowing, extremely hot outermost layer of the Sun. Although the corona is not on the Sun's surface, it is hotter than the actual Sun. As we all know, the Sun is super hot. It provides us with warmth, light, and energy here on Earth. But did you know that there are parts of the Sun that are actually cool? These are called sunspots. Sunspots are areas on the Sun's surface that are cooler and less bright than surrounding areas, are caused by the Sun's magnetic field, and occur in cycles. Scientists must use special telescopes to observe these spots because, like the rest of the Sun, they are dangerous to look at with the naked eye. Sunspots are cooler than the rest of the Sun. They have a slightly darker color than the rest of the Sun and have a strong gravitational force. The average size of a sunspot is as large as our Earth. Sunspots appear and disappear about every 10.8 years, and scientists use them to study the behavior and changes of the Sun. Ultraviolet radiation. Have you ever gotten a sunburn before? Then you have felt the dangerous effects of ultraviolet radiation. When you go to the beach, it is necessary to protect yourself from the sun. You need to bring sunglasses, a hat, and sunscreen. Why? It's because of the sun's ultraviolet radiation. Ultraviolet radiation is a type of energy that comes to the Earth from the sun, can damage skin and cause cancer, and is mostly absorbed by the ozone layer. The sun gives off light that we classify at various points on the electromagnetic spectrum, but it's ultraviolet rays that can cause sunburn and harm our skin. We are very fortunate to have our ozone layer protecting us from most of the sun's harmful rays. The ozone layer is part of the stratosphere with a high concentration of ozone. It absorbs most of the sun's harmful ultraviolet radiation. This important layer can be found 6 to 30 miles above the Earth. Ozone is a natural gas form of oxygen that, when found in the stratosphere, miles above the Earth's surface, can effectively block out harmful ultraviolet radiation. Although our ozone layer blocks 97 to 99% of these harmful rays, there is evidence that suggests that our ozone layer is depleting, leaving us vulnerable to dangerous ultraviolet radiation. Ozone depletion is the thinning of Earth's ozone layer caused by chlorofluorocarbons, CFCs, leaking into the air and reacting chemically with ozone, breaking the ozone molecules apart. Because we rely on the ozone gas in the stratosphere to protect us from the ultraviolet radiation, the less ozone molecules there are, the more vulnerable we are to the harmful rays. Many countries have banned the use of CFCs in any business's production. Solar energy. Without the sun, life on Earth would be impossible. It gives us warmth, light, and energy. Solar energy, that is. Solar energy is energy from the sun that is clean, inexhaustible, and can be transformed into electricity by solar cells. We have many different sources of energy. One of the most reliable and cheapest is the sun. As the sun's rays or radiation reaches the Earth, we are able to convert it into energy to heat our water, homes, and buildings, and provide other forms of electricity. We are able to convert the radiation into solar energy through the use of solar collectors, a device used in an active solar heating system that absorbs radiant energy from the sun. Solar collectors are able to absorb and collect that solar energy provided by the sun. Many people and buildings have added solar panels to the roofs of their houses to help harness the energy to heat and provide electricity in their homes. Other thermal power plants are built to absorb the sun's solar energy to power generators. Solar energy isn't harmful to our environment, but it is reliant on the sun's constant radiation. So places that don't have lots of sun don't benefit as much from solar energy as sunnier locations. Revolution, ellipse, equinox, solstice, and eclipse. Did you know that different countries experience different temperatures at the same time? It's true. When it's summer in the United States, it's winter in Australia. And when it's fall in the United States, it's spring in Brazil. This happens because of the revolution of the Earth. Revolution is the Earth's year-long elliptical orbit around the sun. The Earth revolves around the sun in an oval-shaped path. This slightly oval path is referred to as an ellipse. Ellipse is the elongated, closed curve that describes Earth's year-long orbit around the sun. Remember that the Earth is slightly tilted on its axis. The revolution of the Earth and the tilt and rotation of the Earth on its axis is what causes changes in seasons. When the Earth is tilted with the northern hemisphere towards the sun, it is summer in the northern hemisphere and winter in the southern hemisphere. On the day the sun is at its greatest distance north or south of the equator is called the solstice. Solstice happens twice a year when the sun reaches its greatest distance north or south of the equator. The summer solstice is the longest day of the year because that's the day when the northern hemisphere will be tilted at its greatest angle toward the sun. It is warmer and receives more daylight on that day. At the same time, the southern hemisphere is tilted away from the sun and is therefore cooler and receives less daylight. While it is the summer solstice in the northern hemisphere, it is the winter solstice in the southern, and vice versa. As months pass and the Earth continues in its revolution around the Sun, it next experiences an equinox. During the day of the fall or spring equinox, the Sun is directly over the equator, so neither the northern or southern hemisphere is getting direct sunlight. Instead, our tilted Earth seems to straighten out and spin in direct line with the center of the Sun. Equinox happens 2 times a year, every spring and fall, when the Sun is directly over the equator and the number of daylight and nighttime hours is equal worldwide. The term equinox, derived from the Latin words equal and night, is appropriate to describe this day because there is an equal amount of daytime and nighttime everywhere on Earth. The Earth rotates on its axis and revolves around the Sun. The Moon also revolves around the Earth. So every few years, a solar eclipse happens. A solar eclipse is when the path of the Moon, revolving around the Earth, goes directly in front of the Sun. This causes the Sun's light to be blocked from Earth. The Sun is the largest and most massive object in our solar system. It provides heat, light, and energy to everything in the real world.